One of the basic concepts of digital recording that you'll need to understand is bit depth. Digital recorders use a stream of these bits to determine the amplitude of an audio system, and there are three different popular audio bit depths. There's 16-bit, 24-bit, and 32-bit. Now, the bit depth determines the dynamic range of an audio system, and higher bit depths allow for a wider dynamic range. Now, the reason that I say wider dynamic range instead of a higher dynamic range is because it doesn't improve the headroom of your audio system to record in higher bit depths. What it does do is it allows for more nuance to be recorded because the dynamic range is wider. In other words, from whispers to roars can be more accurately represented by using higher bit depths. And every time you add one bit to the bit depth or word length of an audio system, you double the dynamic range. Now let's take a look at an audio waveform inside of Cubase. You can see that the audio waveform is comprised of peaks and valleys, and the bits are being turned on and off to represent this difference in volume in the peaks and the valleys from the very quietest amount of audio signal, which is known as infinity, or the center of the audio waveform. That's the quiet stuff. All the way up to 0 dB, which is the maximum value that you can send cleanly into an audio system at its peak or at its valley. You'll notice on both extremes of this graph, it goes from infinity to 0 on both extremes. So that is the dynamic range of this particular audio waveform. Now let's simplify this and look at a very, very simple audio waveform. This is a single cycle of a sine wave. It's a very, very simple audio waveform, and it's going to work perfectly for this demonstration, and I'm going to go ahead and fill it in with color so that we can see it a little bit better. Now, as I just mentioned, the dynamic range is the measure from infinity, or the center of the audio waveform, either to the top or to the bottom, of the maximum amount of signal that you can record on either end of the audio waveform. That center measurement to either extreme is the dynamic range of the audio system. And all bit depths have a maximum value of 0 dB. Again, just by adding more bits or going from a 16-bit to a 24-bit system will not give you more headroom. It allows for more variation in the amount of amplitude that you're recording. So in this example, our audio waveform is going to the very, very extreme of the peak and the very, very extreme of the valley. And what that means in this example is that this sine wave is going to the very, very peak and valley of the complete dynamic range of this digital system, depending on what bit depth we're recording in. So it's also important to understand that you can't go past those points, because if you exceed 0 dB, you'll clip or distort the audio pathway, and so you don't want to do that. And so that's how you measure the dynamic range of an audio system. Now let's use a 16-bit word length or 16-bit depth as an example. These are bits 1 through 8 of a 16-bit audio system, and these are bits 9 through 16. And it's this ladder of bits that the computer uses to digitize the audio waveform and determine the waveform's amplitude. So, a 16-bit audio system provides about 65,000 degrees of amplitude resolution, or, more accurately, a dynamic range of 96 dB, and that's a pretty wide dynamic range. And the reason that I use 16-bit is because audio CDs always have been 16-bit. But remember what I said about using higher bit depths? In other words, every time you add one bit to the bit depth or word length, you double the dynamic range. So it's an exponential curve. That means that a 16-bit audio system has about 65,000 degrees of resolution. If you were able to add one bit of resolution to an audio system, you would double that number. So now we're up to 131,000 degrees of resolution. But there's no such thing as a 17-bit recorder, so let's use the next popular bit rate, which is 24-bit. Since it doubles every single time, you now have 16.7 million degrees of amplitude resolution. And by the time you get to 32-bit, you have 4.2 billion degrees of resolution. Now, instead of using degrees of amplitude resolution, let's use decibels, because that's a better way to describe what dynamic range is. A 16-bit audio system has 96 dB of dynamic range. A 24-bit audio system has 144 dB of dynamic range. And a 32-bit system has a ludicrous amount of dynamic range, 1,536 dB of dynamic range. So what most people do is they will record in 24-bit or 32-bit because they have a wider dynamic range. But it's also important to understand that the dynamic range of audio equipment is 120 dB. There's a limit of how much dynamic range the copper and the digital to analog converters in today's audio equipment are able to reproduce accurately. So with 120 dB of dynamic range, it looks like 24-bit would be the best thing to record in because it has a higher dynamic range than 96 dB, and it definitely gets us up to the limit of audio equipment, which is 120 dB. So you may be asking yourself, why even record in 32-bit? Well, there's actually two really great reasons to do so. The first reason is because the audio engine inside of Cubase is natively 32-bit. It does all of its processing in 32-bit, so you might as well capture it in 32-bit anyway. But the biggest and most important reason why is because once the audio is recorded into Cubase, it cannot be clipped. That means that you can push the volume as hard as you need to, and you'll never distort the internal processing of Cubase in 32-bit. The only disadvantage in recording in 32-bit is that it uses more hard drive space, but with hard drives being as cheap as they are, that's not a big deal. So I'm going to recommend that all of your recording inside of Cubase be done at 32-bit, and this is how you set it up. You have to set your bit depth inside of Cubase before you do any recording at all, and you do that by going under the Project pull-down menu and selecting Project Setup. In the Project Setup window, the record format is going to be measured in bits, and Cubase can record in all three of those popular bit depths. So you can select 16-bit, 24-bit, but I'm going to recommend that you select 32-bit floating point as your bit depth for all of your Cubase projects. Once you've set it to 32-bit, you can select OK, and then you can save the project and start recording your audio tracks or doing your mastering. But let's pretend that you didn't have your Cubase project set to 32-bit. Maybe it was already set to 24-bit or 16-bit. If you change it now, with other tracks already recorded, you're actually not going to be increasing the bit depth of any of those originally recorded files. So make sure that you do this before you start any recording or mastering. So bit depth is all about dynamic range, and now we need to talk about how to maximize your dynamic range.